Okay, dudes. What are we going to be doing now?
We're still going to do some fraction stuff. Yeah.
Yes, we're still going to do some fraction stuff. And don't forget what we talked about in the intro to chapter 6. We talked about a little this. Do, shake your booty. Okay? So, we're going to make sure, if you didn't watch that video, watch it. Okay? It really gets these fractions down. We'll do a little more formal stuff coming up here. Alright, so we're going to simplify fractions. Our objective is, well, to simplify fractions. Notice that's how our text goes, and that's, it's pretty straightforward. So, how are we going to do that? Well, let's make an observation. Now, you guys have been simplifying fractions forever. You know how to simplify this. But how do you actually do it? I know you say, well, 6 goes into this guy 3 times. 6 goes into this guy 5 times. Therefore, it must be 3/5. But let's actually think about what we're doing. We're using some properties of algebra to simplify this thing. We're actually factoring that 18 down. Well, isn't that, let me see, isn't this 3 times 10? Yes. Isn't this 3 times 6? Yes. Well, let's further factor it. Isn't this 3 times 3 times 2? Yes, it is. And isn't this 3 times 5 times 2? Yes. Did you hear that Yoda voice coming out? Use the force. Now, I had to do a horrible Yoda impression. Now, I'm looking at this guy, all right. And you start doing this thing you call canceling, okay? You're not really canceling things. You're noticing, you're making an observation. You're noticing that this 3 over 3, this whole thing here is the same thing as writing it like this. 3/3 times 3/5 times 2/2. And you notice, what number is this? That's a 1, man. And that's a 1. So this whole thing must be equal to 3/5. But what you do is you say, all right, I can reduce because there's a common factor here and there, and there. So when you see these crazy fractions, you can reduce too. But notice that I can't write 18, because we know that this is equal to 3/5. We've shown it. I can't write 18 as 10 plus 8 like this. I can't write it as, it's 10 plus 8 over 30. And walk up to this and say, oh, 10 and 30, I can reduce that to 1/3, and this ends up being 8/3. No, it's not going to work. You can reduce when you have factors, when you have a product, when it's something times something times something over something times, it's got to be factored. So when you have common factors, not common addends or parts of a sum. So I need to break this down, I need to factor this, I have to get it into something times something. So I look, monomial factors, I notice 2m. 2m fits in this guy. 2m times 2m is 2m squared. Plus, how many times 2m going to do? 1. Put down here, and this guy, if I factor this, is 2 times 3 times m times m. So now I have to reduce this guy. I have all these factors, I could put this guy in parentheses and made you feel better, and all of these guys too. I'm going to reduce. There's a common 2. There's also a common m. So what am I left with? 2m plus 1 over 3m. I cannot reduce this with this. This is not a factor. M is not a factor up here. It's a factor of this term, of this sum, but it's not. If it was m times something, and this is m times 3, then I could do it, but it's not m times something. It's m, well, it is. It's m times 2 plus. You see that plus, you watch out. Now it's part of a sum. There's a little sum up there, okay? Not a product. And with a little more experience, you'll get better at that. But common mistakes. So, remember, you cannot divide by 0. You must restrict the variables in the denominator, excluding any variables that make the denominator equal to 0. Why can't we divide by 0? Because what is division? It's kind of like the opposite of multiplication, right? It's the inverse. If I do 5 times 3, I get 15. If I do 15 divided by 3, I get 5. Why? Because it's saying, how many times must I add this to itself till I get here? Well, let's see. 3 plus 3 plus 3 plus 3 plus 3. If I add 3 to itself 5 times, I will eventually reach 15 evenly. And this says, how many times must I add 7 to itself to reach 42? Well, let's start counting. 7, 14, 21, 28, 35, 42. I added 6 of them. Well, look what happens when you divide by 0. How many times must I add 0 to itself to reach 12? I could add 0 plus 0 plus 0 forever, for infinity. So wouldn't it just be infinity? Yes, it would be if I ever got there, but I never do. I'm never getting there. You're never getting there. You're still going to be at 0. It's never going to get to 12. Therefore, it doesn't exist. We would go like this. So you can never have a 0. It just does not make sense, people. Thou shalt not divide by 0. All right. What's happening here? I see lots of things happening. Mine. I see a difference of two squares. Mine. Difference of squares. How do I do that? X plus 3. X minus 3. What's going on here? 2x plus 1. 3 plus x. Is it factored? Yes. This is something times something. Are one of these parts of this going to be, yes, part of the product? Here we go. These are the same. Isn't x plus 3? Yes. Whoa, whoa. Okay. Now, I reduced it. I ended up with the x minus 3 over 2x plus 1. I can't do this now because now I have a difference up there and a sum. It's not a product anymore. I can't. They're not parts of a product. But I have to put some restrictions on. So I say, when will this be 0? This will be 0 when either this is 0 or this. So my question is, when is 3 plus x 0? When x equals 3. Or sorry, negative 3. Because if this is negative 3, this part becomes 0. 0 times this makes the bottom 0. That's a no-no. My other question is, when does 2x plus 1 equal 0? Well, when x equals negative 1/2. And I can just take it by, I can really just set these equal to 0. I can write 3 plus x equals 0. Solve for x, subtract 3x equals negative 3. 2x plus 1 equals 0. When? Well, when 2x equals negative 1. And that happens when x equals negative 1/2. So x cannot equal that or negative 1/2. Those are my restrictions. Remember, put your restrictions on before you reduce. Factor, restrict, reduce. Bingo, lotto. There we go. What are we doing now? Oh, sweet. Now we have some thing going on here. I don't know. What am I supposed to be doing here? What is this? Oh, it's already factored. Duh. All right. So I have this guy here. I factor it. Boom. Look at this guy here. Factor it. Boom. Look for common factors. I've got some. But before I factor, got to put my restrictions on. When is this guy going to be equal to 0? Well, when x equals 1. So x cannot equal 1. When is this part going to be 0? When x equals negative 2. Can't be negative 2 either. Now I can reduce. Wait a minute. No, that's not the same. Oh, look at those guys. Are they the same? What's the opposite of this? Let's see. Suppose I factor a negative 1 out. Is negative 1, that would switch the signs. This would become negative 1 and positive x, wouldn't it? Let's see. Negative 1 times negative 1 is positive 1. Negative 1 times positive x. Yes. So this is an identical statement, identical expression as this little part of this product. So I'm going to rewrite this like this, and if I do, I have, let's see what happens. This becomes x minus 1. Isn't x minus 1 the same thing as negative 1 plus x? Yes. So you take the negative of a difference, you're just kind of switching them. So if I put a negative out here, this becomes x minus 1, which is the same as this. So just take care of that negative. Isn't that a great trick? Just put a negative on the outside and just switch the signs on the inside. Unbelievable! 2x plus 3 over, make sure you distribute that, negative 2 minus x. Good. All right. I'm running out of time here, and I've got a ton of slides to get through. Not really, but we have 2 minutes, and I've got to get through this stuff. So then you're asked here to solve for x. Well, I've got to get x to all alone on one side. So a way you can do this is you can actually just get the x terms together on one side. So that's what I'm going to try to do. I'm going to subtract bx from both sides. So let's subtract bx. I'm going to end up with ax minus bx, and I'm going to add this a squared over here equals a squared minus b squared. And what will happen is here, I'm going to have ax minus bx. I can factor the x out. X equal x times a minus b, right? So notice I brought this guy over there and this guy over there. And this factors to a minus b times a plus b. I'm trying to get the x alone. Oh, I can divide by a minus b. Both sides. What happens? Boom. But wait a minute. In any step of an equation or anything you're doing, if you're ever dividing by variables, you have to restrict them, man. So when does a minus b equal 0? Well, if I add b to both sides here, doesn't that happen when a equals b? And if it happens when a equals b, there's my restriction. A just can't be b, and it can be anything else but b. Nice. All right, I've got a little bit of time to do this one. Very last problem. Here we are. We're going to solve for x. So here we go. 2n times x minus n. So let's see. I'm going to multiply. I get 2nx minus 2n squared equals x minus 5n plus 2. Let's see, could I get my x terms on one side? Let's subtract x from both sides, and let's bring that guy over there. So I'm going to add 2n squared over here, and I'm going to subtract x over here. So I get 2nx minus x equals, and I'm going to rearrange this guy so it looks like this, 2n squared minus 5n plus 2. And I'm going to have 10 seconds left. What I'm going to do is I'm going to factor the x out of here. I get 2n minus 1, and you end up getting 2n minus 1, blah, blah, blah. And you factor it out. You do the same thing you did before. Have a great day!